Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic I get asked about all the time: how to find the perfect laptop that excels at both coding and gaming. It's a tricky balance. You need a machine that can compile complex code in a flash, but also render stunning virtual worlds without breaking a sweat. So, if you're a developer by day and a gamer by night, you're in the right place. In the next 7 minutes, we'll break down everything you need to know, component by component, so you can make an informed decision and get the best bang for your buck. Let's get started. First up, the heart of your machine, the central processing unit, or CPU. For our dual-purpose laptop, the CPU is non-negotiable. For coding, a powerful CPU with multiple cores and high clock speeds means faster compilation times, smoother multitasking between your IDE browser and virtual machines, and a more responsive workflow overall. When you switch over to gaming, that same powerful CPU prevents bottlenecks, ensuring your graphics card can perform at its peak. So, what should you look for? On the Intel side, the Core i7 and Core i9 processors are your best bet. Specifically, look for the H-series or HX series chips, like the Core i7 13700H or the Core i9 13980HX. These are high-performance mobile CPUs designed for demanding tasks. For AMD, their Ryzen 7 and Ryzen 9 processors are fantastic alternatives. The Ryzen 7 7840HS or the Ryzen 9 7945X, for example, offer incredible multi-core performance that will chew through code and handle modern games with ease. A good rule of thumb is to aim for at least 8 cores and 16 threads. This will give you the headroom you need for both serious development and high-end gaming for years to come. Next, let's talk about the graphics processing unit, or GPU. While you can code on integrated graphics, for a premium gaming experience, a dedicated GPU is absolutely mandatory. This is what renders the game worlds, processes textures, and pushes high frame rates. Modern game development, especially with engines like Unreal Engine 5, also benefits hugely from a powerful GPU for real-time rendering and asset creation. For a great balance of price and performance, NVIDIA's GeForce RTX 40 series is the current king. An RTX 4060 laptop GPU is a fantastic sweet spot. It delivers excellent 1080p and even 1440p gaming performance, and it gives you access to crucial features like DLSS 3, which uses AI to boost frame rates, and powerful CUDA cores that can accelerate certain machine learning and data science tasks. If your budget allows, stepping up to an RTX 4070 will provide a significant performance uplift, making it a great future-proof option. If you're looking at last-gen models for a better deal, an RTX 3060 or 3070 is still a very capable choice. On the AMD side, the Radeon RX 7600 MXT or 7700S are competitive options, offering great raw performance. Now, let's move on to memory, or RAM. For our hybrid use case, 16 GB is the absolute minimum. Coding, especially with Docker containers, virtual machines, or large datasets, can be very RAM-intensive. Having multiple applications open, like your code editor, a dozen browser tabs, a local server, and a communication app will quickly eat up 8 gigs. For gaming, 16 GB is also the current standard for a smooth experience in most modern titles. However, if you can stretch your budget, 32 GB is the real sweet spot for a power user. This gives you plenty of breathing room to run multiple virtual machines, handle massive codebases, and keep everything running smoothly without ever worrying about your system slowing down. When looking at specs, also pay attention to the speed. DDR5 is the new standard, and faster speeds like 5200 MHz or higher will provide a small but noticeable boost in both gaming and productivity tasks. Let's talk storage. Speed is the name of the game here, and that means a solid-state drive, or SSD, is a must. The days of slow, mechanical hard drives are over. An NVMe SSD will dramatically reduce load times in games, boot your operating system in seconds, and make opening large projects feel instantaneous. For capacity, 1 TB should be your starting point. Games are getting bigger and bigger, with many AA titles easily exceeding 100 GB. Add your development tools, project files, and operating system, and a 512 GB drive will fill up faster than you think. If you work with large video files or have a massive game library, considering a 2 TB SSD or a laptop with a second M.2 slot for future expansion is a very wise move. Of course, you'll be staring at this machine for hours on end, so the display is critically important. For a great all-around experience, look for a screen with a resolution of at least QHD, or 2560 by 1440 pixels. This gives you sharp text for coding and a beautiful, detailed image for gaming. For refresh rate, 120 Hz is the minimum for smooth gaming, but 165 Hz or even 240 Hz will provide an even more fluid and responsive feel. Also, pay close attention to color accuracy. A panel that covers 100% of the sRGB color gamut will ensure colors are vibrant and true to life, which is great for media consumption and any front-end or design work. A brightness of at least 300 nits is also recommended so you can use the laptop comfortably in various lighting conditions. Beyond the core specs, the user experience components are just as crucial. You'll be typing thousands of lines of code, so a comfortable, tactile keyboard with good key travel is essential. Backlighting is also a must-have for late-night coding or gaming sessions. The trackpad should be large, responsive, and support precision gestures. Since you'll likely use an external mouse for gaming, a great trackpad is more for productivity on the go. Powerful components generate a lot of heat, so a robust cooling system is non-negotiable. Look for laptops with dual fans, multiple heat pipes, and large ventilation areas. Poor cooling will lead to thermal throttling, where your CPU and GPU slow down to prevent overheating, drastically reducing performance in the middle of a compile or a boss fight. Reading reviews that specifically test thermal performance under load is a great way to verify a laptop's cooling capabilities. Next, battery life and portability. This is often the biggest trade-off with powerful gaming laptops. Don't expect all-day battery life when you're pushing the hardware. However, some models offer better efficiency than others. Look for laptops with a large battery, typically 80 watt-hours or more, and features like NVIDIA Optimus, which can switch to the power-saving integrated graphics for light tasks. As for portability, a 15 or 16-inch model usually strikes a good balance between screen real estate and carrying weight. Finally, the operating system, Windows, is the default for PC gaming and supports the widest range of development tools. For most people, it's the most straightforward choice. Mac OS, found on MacBooks, is fantastic for development, thanks to its Unix-based foundation, but its gaming library is much more limited. Linux is a developer's dream for its customizability and power, and with tools like Proton, gaming on Linux has become incredibly viable. Many developers even dual-boot Windows and Linux to get the best of both worlds. So, to summarize, finding the perfect laptop for coding and gaming is all about smart balancing. Prioritize a powerful CPU like a modern Core i7 or Ryzen 7, and pair it with a capable dedicated GPU like an RTX 4060. Aim for at least 16, but preferably 32 GB of DDR5 RAM, and a fast 1TB NVMe SSD. Don't forget a high-resolution, high refresh rate display, and a comfortable keyboard. Check reviews for thermal performance, and set realistic expectations for battery life. By focusing on these key areas, you can buy a versatile machine that will serve you well, whether you're building the next great app or conquering the latest virtual battlefield. I hope this detailed guide was helpful. Buying a new coding and gaming laptop is a big investment, so take your time and do your research. If you have any questions, drop them in the comments below. Thanks for watching, and don't forget to like and subscribe for more tech guides. See you in the next one.